Hello guys, welcome to my video. In this video, let us know how to check whether given number prime or not. Myself T. Jashwant Kumar Reddy, I'll be guiding you through this video to find whether a given number is prime or not. What is a prime number exactly? A prime number is a number which has two divisors, one and itself, and divisors must be unique. Consider examples 0, 1, 2, 6, 7, 9, which are numbers. 0 is not a prime as division is not possible by 0. 1, it is not prime as there is only one unique divisor which is 1. 2 has two numbers 1 and 2 in between 1 and itself. So let us count the number of divisors. 1 is a divisor of 2. 2 is also divisor of 2. In total we have two divisors which satisfies the condition of a prime number because 1 and itself are unique for the number 2. So it is a prime number and it is the only even prime number in the number system. Next comes the number 6. So from 1 to 6 we have 6 numbers. Let's see 1 which is a divisor of 6, 2 is also divisor of 6, 3 is also divisor of 6, so we came up to 3 counts, 4 is not a divisor of 6, 5 is not a divisor of 6 and 6 is a divisor of 6. In total we have a count of 4 divisors for the number 6, which means it is not a prime number because to be a prime number the number must have only 2 divisors. So clearly it is not a prime number. Next comes the number 7. So 1 which is a which is a divisor of 7, 2 is not a divisor of 7, 3 is not a divisor of 7, 4 is not divisor of 7, 5 is not divisor of 7, 6 is also not divisor of 7, but 7 is divisor of 7. So we have count equal to 2 which is 1 and itself are the divisors, so it is a prime number. Next comes the number 9. Can you guess whether it is a prime or not? Absolutely, it is not a prime because we have 3 divisors, 1, 3 and 9. So let's see. 1 is a divisor of 9, 2 is not divisor of 9, 3 is divisor of 9. So we already reached count 2. So 4 is not divisor of 9, 5 is also not divisor of 9, 6 is not divisor of 9, 7 is not divisor of 9, 8 is not divisor of 9, 9 is a divisor of 9. So 1 and itself are always divisors of a number if you observe properly, because in the given examples of except 0 and 1, so for number 2 1 and itself are its divisors, and for 6 also 1 and 6 are its divisors, for 7 also 1 and itself 7 are its divisors, for 9 also 1 and 9 are its divisors. So for 9 it is not a prime number because we have 3. So the input format is we have a number which is n. It can be any number, any positive number. The output is true or false. We return true if it is a prime number, which is the input n. If n is not a prime number, we return the false. Let us go through the pseudocode. What we did exactly to know whether a number is a prime or not. We have a function call with an parameter of number. So we get the input from the function as parameter. Then comes the base condition. 0, 1 or negative numbers are not prime numbers. So we put it as base condition. So first we check whether the given number is greater than 2 or not. Next comes the count variable to count the number of divisors. We iterate I from 1 to n. Sorry for the mistake in the code. It should be 1 to n. And if I is equal to 0, n% I equal to 0 means it is a divisor. If we find any divisor, we need to increment the count. Then comes the condition. If count after calculating the total number of divisors, we check if the divisor count is 2. It is a prime number, else it is not a prime. Here comes the question. Do we have to check all numbers from 1 to n to know whether the given number is prime or not? Consider example 100. To know whether 100 is a prime or not, do we have to check all the 100 numbers? Is it? I can say it is not a prime because it is divisible by 1, 2 and 100. But how can a computer know? Let us improve the logic. We know 1 and itself will always divide the number. So if n is greater than 2, so we can skip them, right? So consider the number 100. If any number except 1 and itself, like 100, in between if we find any number, it is not a prime, right? If we find 2 as its divisor, 100 is not a prime. 5 is a prime, and 9 is not. We have 3 in between, so it is not a prime. So let us consider 2. We don't have any numbers except 1 and 2, so it is obviously a prime number. 6, we have numbers 2, 3, 4, 5, and we find 2 and 3 as its divisors, so it is not a prime. So consider 7. We don't have any divisors in between 1 and itself, so count equal to 0, so it is a prime number. And for the number 9, we have 3 as its divisor, so it is not a prime number. So to be a prime number, it does not have any divisors other than 1 and itself. Still, we are checking from 2 to n minus 1. So do we have to check all numbers between 1 to n, which is 2 to n minus 1, to know whether the given number is prime or not? The answer is, if you find even one divisors while iterating, you don't have to continue the process. It is not a prime number. Okay, let us consider the number 9. So we eliminated 1 and itself, as we know they are its divisors, but consider 2, it is not a divisor, but 3, it is a divisor. So do we have to continue the process? We know 1 and itself, it has two divisors already, and we find the third divisor, which means it is not a prime. We don't have to keep going our process. We can simply say it is not a prime. Okay. So based on our improvisation, let's change our function a little bit. Count variable is not required because we can remove the count, because we are making it as if we find other than any number from 1 and itself, it is not a prime, and we are changing the variable from 2 to n, like I moves from 2 to n minus 1. So we don't have to have a count variable to count the number of divisors. So I just removed it. For I mean, next change is I should be moving from 2 to n minus 1, and instead of incrementing the count, we can simply return false, because it is not a prime if we find any divisors in between 1 to n. Okay, so we just changed it. So it is the updated pseudocode. Still we are checking from 2 to n minus 1, and we stop if we find any number in between. But still, do we have to check n minus 1? So if it is a prime number, there will be no divisor, so we'll completely check every number, but we don't have to do that. Actually, we must check only till square root of n, because multiplication exists in pairs. Okay, consider number, I'll explain you with an example. Consider number 16. We have in between numbers 2 to 15. Okay, so consider a number x and number y. If multiplied, we get a number n. Okay, x is a small number and y is a bigger number. Consider it. Suppose we take x from start. Okay, so now n is 16. So if we take 2 as x, there should be other pair, no? So to be a divisor, what is a divisor? It can divide the number. When we divide the 16 with 2, we get answer as 8. So 2 multiplied by 8 gives 16. So 2 and 8 are a pair. Okay, which are divisors. So we get divisors in a pair. So 2 has a pair of 8 as the divisors of 16. Next, consider 3. But is it a divisor of 16? No. 3 and 6 are divisor of 18, and 3 and 5 are divisor of 15, but not for 16. Okay, and if you see the 4 fours, it is 16. So if you see the covering area, the x has very small cover area, and if we don't find any x, as y is dependent on x, there will be no divisors. So we should must check till only square root of n. Let us see why we need to check only till square root of n. See, when x and y are meeting, we should stop the point. Okay, so x and y are independent, so if there is no x, there will be no y, and if there is no x or y, then it is a prime number, right? There will be no divisors. So range of x is from 2 to meeting point of x and y. So if you see the red color line border, it is from 2 to the point where x and y meets. So when if x and y are meeting, then x and y should be equal, right? So x multiplied by x, which is x square, is equal to n. If we move the square of x to the right side, it becomes square root of n. So x is square root of n, and we have to check only till square root of n to know whether the given number is prime or not. So range of x is 2 to square root of n. If there is no divisor x, then it is a prime. So we check for divisor from 2 to square root of n. So let us change our pseudocode. The function is as it is, as we discussed before. Only change is the I should change from 2 to square root of n. So thank you one and all for this wonderful session.